Imagine building a complete international airport in the middle of the sea, not on a bridge or a natural archipelago, but literally on an artificial island constructed with millions of cubic meters of landfill, facing tides, subsidence, limestone caves, and an ambitious schedule. It sounds like fiction, but this project actually exists. It's the Dalian Digital International Airport, the first offshore airport in mainland China, currently under construction off the coast of Liaoning Province. With a terminal spanning 500,000 square meters and runways for wide-body aircraft, the project has moved over 180 million cubic meters of landfill, pushing geotechnical engineering limits. A floating city that advances daily with cutting-edge technology and solutions that seem straight out of national aeronautics and space administration manuals. Take a few minutes to dive into the core of this Chinese titan, where every driven pile, every meter of compaction tells a story of overcoming challenges, innovation, and engineering taken to the extreme. The new international airport is built in the Bohai Sea, about 4.5 kilometers from the coast of Dalian, in Liaoning Province, in the far northeast of China. The structure rests on a rectangular artificial island of 20.87 square kilometers, with 6.54 kilometers in length, 3 kilometers in width, and a perimeter of dikes exceeding 21 kilometers. This colossal platform is designed to support not only the passenger terminal and runways, but also all the infrastructure for refueling, cargo, power, and security. By the way, it's worth noting that the choice of location was strategic. Dalian is a port economic hub, and the region already serves as an international connection point between mainland China and Pernambuco. First, Campos is caught crossing Serena in a complex maneuver with São Paulo heading in his direction, focused. Study box width is like a withdrawal. The idea of a new airport for Dalian emerged in the early 2000s, motivated by three main factors. First, the saturation of Jushuisi Airport, which operates above capacity. Second, the goal to make Dalian a full international hub. Third, limited land for expansion. After initial studies, the project for an offshore airport like those in Kansai, Japan, gained momentum. In 2012, the State Council of China officially approved the proposal. Construction began in 2014, but was interrupted by a series of problems, ranging from changes in the financing model to environmental challenges and the coronavirus pandemic. It was only in 2023 that the project resurfaced with new management, a realistic schedule, and a phased timeline. By July 2025, 94% of the island's area was already formed. 26.3 billion yuan, about $4.3 billion, or even more, approximately 23 billion Ries. By the way, it's worth noting that the project was included in the infrastructure plan, which is part of China's 14th five-year plan. The motivation now goes beyond logistics. The airport has become a symbol of technical achievement over the ocean and a laboratory for intensive application of geotechnics, ground treatment, and large-scale compaction. But it's behind the scenes of construction that the real power of this giant is revealed. Building an entire airport over the sea requires engineering in its purest form. The Dalian Jinjiangwei stands on an artificial platform built with an impressive 187 million cubic meters of compacted soil and various materials, carefully deposited on multiple fronts. With an operational peak of 263,300 cubic meters per day recorded in 2025, this platform is contained by an extensive system of perimeter dikes stretching 21 kilometers, designed with active infiltration control and lateral reinforcement. To withstand hydrodynamic action and differential settlement of the seabed, the core of these dikes uses alternating layers and heavy riprap, geotextiles, and compacted soils, optimizing drainage and increasing lateral stability during the initial phases of preloading. Once the external barrier was completed, the land reclamation process began, in which the interior of the containment ring was filled with dredged sediments, graded gravel, and sandy soil, laid in successive layers with precise control of thickness and moisture. Each layer was subjected to compaction proctor and density tests, ensuring minimum parameters for shear strength and deformation modulus. The most demanding technical challenge, however, was the stability of the highly compressible seabed. That's why about 12 million prefabricated vertical drains, PVDs, were installed, covering the entire area of the future terminal and runways. These drains speed up the process of pore pressure dissipation, promoting the accelerated consolidation of the deep layers. During this period, vertical settlements were monitored in real time using extensometers and pore pressure sensors, allowing for dynamic adjustments to the surcharge loads. At the same time, dynamic compaction was carried out using 90-ton hammers, applying impact energy of up to 1,800 ton force per meter. Each blow drove energy up to 13 meters into the subgrade, inducing reorientation of soil particles, closing of pores, and increasing relative density, especially in areas with a predominance of silt or fine sand. Sonic integrity and load tests were used to monitor each pile, and equipped with traceability QR codes, linking parameters such as depth, soil type, execution time, and tip resistance in a centralized digital database and building information modeling, thus ensuring total real-time visibility for the engineering team. The Geotechnical Instrumentation Network is one of the most advanced ever implemented in port and airport projects. More than 1,700,000 readings have been taken so far, monitoring absolute and differential settlements, pore pressures, horizontal displacements, and groundwater levels at different elevations. All this data is processed on an integrated platform with predictive alert intelligence, capable of detecting abnormal settlement or lateral movement trends, allowing corrections before they reach critical levels. This approach ensures not only the safety of the construction, but also greater agility and executive decision-making from a structural point of view. The architectural layout of the terminal, designed by BG Institute of Architectural Design in Biagi, adopts a radial form with 6 roof ends, covering approximately 500,000 square meters, enables efficient boarding and disembarking with average walking distances under 8 minutes. The building is divided into domestic and international sectors with separate operational platforms, allowing modular expansion. Finally, the construction schedule foresees the completion of these main structures by 2028, with partial delivery of operational areas in a progressive manner. Full operation, with 4 runways and a total passenger capacity estimated at tens of millions per year, is scheduled for 2035, consolidating the Dalian Ninja Way as one of the most ambitious and sophisticated works of port and airport engineering in the world. Among the island airports of the world, Dalian stands out as one of the most ambitious. With 20 and 27 square kilometers of artificial island, it surpasses in area both Kansai, with 10.55 square kilometers, and the expanded Hong Kong International Airport, with 19.05 square kilometers. The geotechnical complexity is comparable to Kansai, which experienced settlements of over 8 meters after its inauguration, something the Chinese are trying to avoid with aggressive preloading and state-of-the-art instrumentation. The terminal, with 500,000 square meters, rivals Concourse in Dubai, with approximately 528,000 square meters. In turn, the initial capacity, estimated at 48 million passengers per year and 550,000 tons of cargo, places Dalian among renowned airports, but still far, for example, from Shibu in Amsterdam, according to data from 2020, and the Netherlands airport receives almost 67 million passengers per year, handling 1.5 million tons of cargo. As for the budget, estimated at 23 billion reais, it represents more than double the almost 10 billion reais that will be invested in 66 interventions in Brazilian airports until 2026. With 4 runways planned in the final phase, the airport will be able to receive more than 80 million passengers per year, connecting Dalian to the main hubs in Asia, Europe, and North America. In addition, it's worth noting that the artificial island will also be able to accommodate logistics parks and research areas in aviation and offshore climate control. The project acts as a catalyst for the redevelopment of Dalian's waterfront and accelerates investments in integrated mobility, such as new train lines, subways, and elevated highways connecting the airport to the city. The installed infrastructure will also serve as a foundation for future offshore projects in China, consolidating the country as a global reference in megadevelopments over the sea. Dalian Digital International Airport is not just an airport. It's a statement that engineering, soil science, urban planning, and architecture can work together to achieve the impossible. From the bottom of the sea comes a promise of 21st century mobility and perhaps the most audacious airport project on the planet. An airport that defies gravity, the ocean, and time, and that puts China once again at the center of innovation and infrastructure. Welcome to the future. Thank you for watching this video so far. What did you think of this great international airport in the middle of the ocean? We know there's the Kansai Airport in Japan, for example, but this one is impressive. Leave your opinion in the comments. I would be happy to read all of them. I'll stop here. A big hug and see you in the next video.